All right, we're going to study for quiz 6.6, solving exponential and logarithmic equations. There are just a few things that you do need to know. First, if log base b of x is equal to log base b of y, then x is equal to y. So if you're taking the same log of each argument, then the arguments are equivalent. And if b to the x is equal to b to the y, then x equals y. So if you have the same base of an exponent, then whatever is in the exponent on both sides is equivalent. X equals y. Okay, so basically we need, this is an exponential, so the only thing that could apply to us here is if b to the x equals b to the y, then x equals y. But that's if you have the same base for the exponent, and you do not. In this case, you have 6 to the power of something. If you could write 216 as a base of 6, then we could use the property over here. So I am going to write that 216 is actually 6 cubed. So 6 to the power of 2 minus 3v is equal to 6 to the power of 3. All right, if b to the x is equal to b to the y, then x equals y. So 2 minus 3v equals 3. When you make it x equals y, these are no longer exponents. You have literally unexponented them. That's not a word at all. But you undone the exponent. All right, and then it becomes an easy equation to solve. So negative 3v equals negative 5. It's definitely not negative 5. Whoops. It is 1. All right, negative 3v equals 1, so v is equal to negative 1/3. All right. This one is, I was only going to do the odds, but this one is kind of a little bit harder, I think. Maybe, I don't know. So 64 to the 2n, 1/8. So if we could write this with the same, if we could write these two numbers with the same base, I know I can write 1/8 with the base of 8. That's just 8 to the negative 1. And I know that I can write 64 with the base of 8 as well. That's just 8 squared. So that's what I'm going to do. I'm going to take 64 and turn that into 8 squared. Then I'm going to take 1/8. Okay, so I'm going to rewrite 1/8 as 8 to the negative 1. All right, if b to the x equals b to the y, then x equals y. So let's clean this up to truly have a base of 8 on each side. So 8 to the power of these exponents will be multiplied. So 4n is equal to 8 to the power of negative 1. Now, x equals y. Exponent equals exponent. So 4n equals negative 1. n equals negative 1/4. All right, sometimes you just can't get the same base though, and you have to use log, but they do want you to leave it in exact form. So anytime you write log, you're gonna leave your answer with the word log in it because you will not have a calculator for this quiz. So the first thing that you do is get the base of your exponent by itself. Negative 5 is being multiplied, so divide both sides by negative 5. All right, 11 to the x plus 7 is equal to 9. The only way to bring this exponent down, to bring x plus 7 to no longer be an exponent, is to take the inverse of exponential, which is log. So I have to take log base b, same base as the base of my exponent, so log base 11 of both sides. Log base 11 of this, log base 11 of this. Log base 11 of 11 to the power of x plus 7 is x plus 7. That is equal to log base 11 of 9, which you cannot simplify further than that. Subtract 7 on both sides, and x is equal to log base 11 of 9 minus 7. You cannot combine those any further. All right, I think 14 shouldn't be too hard. And now let's get into logarithmic equations. So if log base b of x is equal to log base b of y, then x is equal to y. Guess what? Log base 7 of something equals log base 7 of something. So 7 minus 2x is equal to negative 4x minus 5. And then it becomes a much simpler equation to solve. Sorry. 2x is equal to negative 12, so x equals negative 6. All right. So, number 16, we've got the same log on both sides. So again, if log base b of x is equal to log base b of y, then x equals y. Okay, so 5m minus 6 is equal to 3m minus 10. So I'll subtract 3m on both sides. So that's 2m. And then we'll add 6 on both sides, so that is negative 4. M equals negative 2. Okay, I forgot to do this on number 15, so I want to take a look back at it. We do need to check that negative 6 is truly an option, right? Because you can't take the log of 0 or of a negative. So if negative 6 makes either of the arguments negative or 0, then it is not a solution. 7 minus 2 times negative 6, that's greater than 0, so we're fine. And then negative 4x minus 5, so negative 6 minus 5, that's 24 minus 5, that's also greater than 0. So we're good on that one. Let's check this one. When we put negative 2 in for the m, that's a negative 10, minus 6 is negative 16. So already when I plug in negative 2 for this m, we are getting a negative in the argument, and that can't happen. So negative 2 is actually not a solution. And since that was the only option we got, there is no solution to this equation.